In the last video, we discussed about scalar and vector. In this video, we are going to discuss about distance and displacement. Distance is a scalar quantity, displacement is a vector quantity. What does it mean? Displacement depends on direction. Distance means the total path length covered, right? Well, come to displacement. Displacement is the shortest distance between initial point to the final point. Okay, displacement is the shortest distance between initial point to the final point. So you can define displacement as delta x equals to x2 minus x1. Here x2 means the final point, x1 means the initial point. Let's take an example for distance. If you are here at point A and move to point B, which is at 10 kilometers far to B, A to B. After that, you return back to point C, which is at 5 kilometers from B. Now, what is the total distance? Distance is 10 plus 5, 15 kilometers. While come to displacement, take the same example. Displacement is the shortest distance between initial to the final point, right? This is the initial point. This is the final point. What is the shortest distance between these two? 5 kilometers. That's the displacement. 5 kilometers. Hope you understand the difference. One more thing, displacement depends on direction, right? Because it's a vector. If you are moving in this direction, 5 kilometers, this becomes a positive 5 kilometers because this direction we are taking it as a positive along positive x-axis. If you move same 5 kilometers in this direction, this becomes negative 5 kilometers because displacement depends on direction. Okay, if you are moving in this direction, that becomes positive. If you are moving opposite direction, that becomes negative. This negative symbol represents the opposite direction. Okay, but this doesn't work for distance because distance is a scalar quantity that doesn't depend on direction. Whether you move in this direction or in this direction, distance is always positive. Okay, let's see a few more examples on distance and displacement. If you started a journey from point A along point B, C to D, suppose A to B is 10 meters, B to C is 5 meters, C to D is 10 meters, then the total distance is sum of all the path lengths, 10 plus 5 plus 10, 25 meters. Now come to displacement. What's the definition of displacement? Shortest distance between initial to the final point. Remember, the shortest distance is always a straight line between initial to the final point. Okay, then the displacement is 5 meters. Let's take another example. Suppose you are traveling in a circular track. You started at point A, the track of radius r, and you come to the point A again. You completed one rotation. Then the distance is the circumference of the circle, that is 2 pi r. But what about displacement? You reach to the same point, right? So initial and final points are same, then the displacement is 0. Similarly, if you started from point A, you reach to point B and return to point A again, then the distance is 2 times this distance. For suppose this is D, distance is 2D. but displacement is 0, because the starting point and the ending point are same, then the displacement is 0. Another example, so suppose this is 4 meters, this is 3 meters, track from A to B to C. Then the distance is 4 plus 3, 7 meters. What's the displacement here? Displacement is always a straight line between initial point to the final point. That is this is the shortest distance. So from the right angle triangle, the length of this side is root over 4 square plus 3 square. That is 5 meters. Then the displacement is 5 meters. I hope you understand the difference between distance and displacement. In the next video, we are going to discuss about speed and velocity.